Everything we know might have started because of a crash involving something outside of our reality. It's an idea that goes against the way we've looked at the Big Bang for a long time, where we saw it as the one absolute beginning. Now there's this suggestion from physics that it was actually a collision between two different universes. This would mean our origin was a violent ripple from that impact, a cosmic crash between parallel worlds instead of just a single spark. It's a different way to think about why certain things in the sky don't seem to fit the usual theories. There is physical evidence that points to us being just one layer of a much bigger multiverse. It involves the idea that a sibling universe might have hit ours and left what looks like a permanent bruise on space and time. You can see it in these massive cold voids that don't really follow the laws of physics as we understand them. There's also the possibility that gravity from another world is still out there pulling on our galaxies right now. It changes how you think about home, if we're actually part of an eternal cycle of rebirth. It makes you consider if there are other versions of reality just drifting there, right beyond where we can reach. There is this area in the constellation of Eridanus that doesn't really fit with how we expect space to look. It's called the Great Cold Spot. It was first picked up by the Wilkinson Microwave Anisotropy Probe satellite, and it's been a problem for astronomers because it's just this massive, freezing void. Usually, the glow left over from the beginning of the universe is pretty even. You expect little temperature changes here and there, but the laws of physics say they should be spread out fairly. But this spot is way too big, and way too cold for any of our current theories to make sense of it. It's like a hole in the map of the sky that shouldn't be there. Some researchers think this isn't just a random gap. Dr. Laura Mersini-Houghton and her team have this idea that it's actually a cosmic bruise. They're saying our universe got bumped by another universe right when things were first starting to grow. It wasn't a small thing, but a massive interaction that left a permanent mark on our reality. So if that's right, the spot in Eridanus is the literal point where two different realities touched each other. It's a scar from a time when we weren't alone. Having something that huge out there changes how we think about our place in the cosmos. For a long time, we've used the Copernican Principle, which says we aren't in a special or unique spot. But a bruise from a collision suggests our universe has a specific history and a boundary that actually got pushed inward at one point. It's evidence that we don't exist in isolation. It makes it look like we're just one patch in a much bigger tapestry of realities. It forces a rethink of the early days of time and how pressures from outside our borders might have shaped the galaxies we see now. Scientists are looking at the world now like it's a thin membrane, and it's just floating inside a reality that is much larger than what we see. It comes out of M-theory. That's the branch of physics suggesting there are more than just the three dimensions we're used to. In that framework, the whole universe is called a brane, which is just short for membrane. It helps to think of it like a flat sheet of paper. If you imagine two of those sheets hanging next to each other in a big room, that room represents a higher dimensional space. Physicists call that the bulk. Most of the time, these two sheets are just drifting there. They're separated by this tiny distance that we can't see or feel, mostly because we are trapped on the surface of our own sheet. Even when they're close, they stay completely separate worlds. They each have their own stars and planets and their own laws of physics. Eventually, that microscopic gap between the worlds can close. Deep in the math of the fourth spatial dimension, these universal sheets can wobble or drift until they finally collide. Neil Turok is one of the specialists who suggests this is what happened at the beginning of time. From our perspective inside the universe, we saw that event as the Big Bang. We used to think the Big Bang was just a single point that exploded for no reason, but this theory says it was the result of two massive objects hitting each other. When these branes make contact, the impact is powerful enough to release an unbelievable amount of energy. That energy turns into the heat and the light and the matter that formed every galaxy we see tonight. It changes how we think about the fabric of reality. Space isn't just a void that appeared out of nowhere. It's a structure that can be pushed or dented or marked by something else. Like when you press two soft surfaces together and they leave an impression on one another, space-time might work the same way. It explains why something like the Great Cold Spot could exist. It isn't just an empty area. It's a lingering ripple from the moment our world was shaken by a neighbor. Looking at the universe this way makes you realize the boundaries of our world might be thinner than we suspected. We aren't in a lonely bubble. We are on a surface that is constantly being influenced by movements in a hidden, higher dimension. There is a strange pattern in the oldest light in the sky that suggests the universe has a preferred direction. This comes from the cosmic microwave background, which is just the fading heat left over from the start of time. For a long time, the thinking was that the universe would look the same no matter where you pointed a telescope, as long as you looked at a large enough scale. Scientists call that isotropy. It's a major part of how we understand physics, this idea that everything is balanced and even. But when they mapped the temperature across the sky, they found something that shouldn't be there. The largest structures in that radiation aren't random. They seem to be lined up in a specific way. It was so unexpected and confusing for physicists that they started calling it the axis of evil. They expected the universe to be perfectly balanced, but instead, it looks like there's a built-in tilt. It's like the cosmos favors one side over the other. If everything started with a simple, symmetrical explosion, there shouldn't be a giant line drawn through the middle of the universe. But when you look at how matter and energy are actually spread out, they seem to follow an invisible path. It suggests the universe didn't expand evenly like a round balloon. Something happened in the past to give it a specific orientation, a top and a bottom to reality that we weren't supposed to find. This alignment acts like a massive compass, and a lot of scientists think it points back to a moment of impact. If two universes collided, that force wouldn't be felt everywhere at once. A crash happens at a point and sends ripples out from there, like a stone hitting a pond. The place where they made contact would have different levels of heat and pressure than everywhere else. That would leave a permanent bias baked into space itself. The axis of evil might be the physical signature of that collision. It's a scar showing where another universe pushed against ours. It forces a rethink of the symmetry of the cosmos. If our world was shaped by an outside force, then it was never a closed system. The forces at the beginning weren't just internal, but external pressures that nudged the newborn universe out of alignment. We are looking at a map that was distorted by a powerful encounter. By following that directional scar, you can start to piece together the mechanics of the impact. It makes you wonder how long that collision lasted, and how much energy was exchanged, and what actually happens to a world when it gets struck by something from the outside. Science tends to borrow names from ancient philosophy when it runs into concepts that don't fit our normal way of thinking. That's where the term Ekpyrotic comes from. It's a Greek word for a great fire or a conflagration that's supposed to clear everything out to make room for a new start. In terms of the universe, it isn't a literal fire, but it's a way to describe the heat and the energy that happens when two membranes of reality finally touch. The theory is that the Big Bang was actually just movement being turned into matter. You have these two universal sheets drifting through higher dimensions, and when they slam into each other, that speed and mass converts into a dense, scorching plasma. That's what eventually cooled down to become the stars and the planets. It's a different way of looking at the beginning than the usual idea of cosmic inflation. Most of the time, we're told the universe just expanded faster than the speed of light because of a force no one can really define. This model replaces that mystery with gravity. It suggests these universes aren't just drifting around, but they're actually being pulled toward one another across these hidden gaps in higher dimensions. As they get closer, the pull gets stronger, and they accelerate toward a massive impact. That process leaves specific fingerprints in the structure of space. It creates these ripples in time called gravitational waves, and it leaves temperature patterns in the sky that look different than what you'd get from a simple explosion. By studying those patterns, Scientists can try to see past the wall of the Big Bang. If the universe came from a collision, it means something existed before our time even started. There's a mathematical bridge there that lets researchers calculate what the conditions were like before our world was born. It makes the beginning of time look less like a one-off event and more like part of a rhythmic cycle. Every measurement of the oldest light in the sky might just be a recording of that encounter. It turns the cosmos into a laboratory where you can see the results of two worlds interacting. The math suggests the boundaries of our reality aren't a dead end, but a way to understand the structure that holds our world and whatever else is out there. The Milky Way is moving at over 1 million miles an hour, and it isn't just drifting. We're being pulled toward a destination we can't actually see. There's a massive migration happening where thousands of other galaxies are all being drawn toward a single point in the sky, and astronomers call that area the Great Attractor. It's about 250 million light-years away from us. It sits right behind the thickest part of our own galactic disk, so all that dust and those stars make it almost impossible to observe directly. We know there is something there with the mass of tens of thousands of galaxies. It's putting out a gravitational pull so strong it doesn't really fit with what we understand about how matter is spread out. When scientists try to count the stars and the gas in that direction, the numbers don't work. There isn't enough visible matter to explain why everything is being pulled that way. A lot of researchers think dense clusters of dark matter are responsible, but there is a different theory that we're feeling an encounter with another world. The idea is that our universe might have collided with a neighboring reality a long time ago. The gravitational fields of those two membranes could have gotten snagged or intertwined. If that happened, the Great Attractor might be a lingering point of overlap. It would be a place where gravity from a sister universe is leaking into ours and dragging our galaxies toward it. That would mean the collision wasn't just a quick bounce. It would have been a messy, long interaction that left parts of our cosmic fabric stuck to another piece. It's like two pieces of fabric that got caught on each other and never quite pulled apart. So the motion of the Milky Way wouldn't just be about internal physics. It would be a response to a force from outside our borders. We're seeing this persistent influence that suggests our universe is still being nudged by a neighbor. It makes you look at these large movements in space differently. We usually think distance acts as a shield, but the Great Attractor suggests something on the edge of our reality can dictate what happens inside it. If this pull is a relic of a collision, then the history of our galaxy is tied to the history of another universe. We're living in the wake of an interaction that is still guiding us through the dark. The map of the sky becomes a record of these old connections, where the forces moving us have roots in a reality we're only just starting to imagine. Vibrations from the very beginning might be the proof that the universe started from a massive impact. We've seen small ripples in space and time when black holes collide. But if two entire universes hit each other, it would have caused a cosmic tsunami. These are called primordial gravitational waves. They're different from the light of the Big Bang because that light was stuck in a thick fog for a long time, whereas these waves moved through the vacuum without anything stopping them from the second that crash happened. They have a specific signature in their frequency and the way they twist through space. It wouldn't look like a normal explosion. To find them, you have to look for a specific pattern of polarization in the oldest radiation we can see. If the universe just expanded by itself, the ripples would be predictable and orderly, but a strike from another universe would leave a chaotic imprint. These echoes that carry the energy of a higher dimension. It's a physical record of what was happening before there were stars or galaxies. It's like a recording of the impact itself, just sitting there in the grain of reality. If those signals can be isolated, the idea of a brane-world collision stops being just math and becomes a historical fact. There are future missions being designed with space-based observatories meant to listen for these low-frequency hums. They'll put detectors millions of miles apart in orbit to catch the stretching and squeezing of space that has been traveling toward us for billions of years. It's as close as we can get to actually seeing the moment of creation. These waves would show the speed and the angle of the collision, and maybe even what the other universe was like. We're at the start of finding out that the vacuum isn't silent, and that the past was much more violent. Detecting these vibrations is the next step because they are the only testimony left of what happened when our world met another one. Matter across the deepest parts of space is caught in a current that nobody can really explain. Scientists used to think the universe was expanding in a uniform way, sort of like a balloon inflating where everything just moves away from everything else at the same rate. But when astronomers started tracking how distant galaxy clusters were moving, they found something that didn't fit that rule. Thousands of these massive clusters are all streaming toward one specific patch of the sky, and they're moving at millions of miles per hour. This isn't just the normal drift you get from space expanding. It's a consistent, purposeful motion that researchers started calling dark flow. It works like a cosmic river, and it's carrying everything in its path toward the very edge of what we're able to see. The part that's unsettling about this discovery is that there's nothing inside our observable horizon that could be causing it. Usually, gravity comes from things we can actually identify, like giant stars or clusters of dark matter. But the force behind dark flow seems to be located beyond the boundary of our universe. Dr. Alexander Kashlinsky led the team that identified this movement, and he suggests this pull is coming from structures in a sibling universe. It would mean that when our two worlds interacted, they didn't just bounce off each other and go their separate ways. An external structure left a gravitational footprint behind, and it's still pulling on our matter today. Thinking about the universe as a fluid system changes how we see those boundaries. If you imagine our reality is just a patch of water in a vast ocean, then dark flow is the evidence of a current that started somewhere far away. It shows our universe isn't a self-contained bubble or a closed system. It's a porous environment, and it reacts to high pressure and massive objects that exist outside of our three dimensions. This neighbor is exerting a constant influence, like a giant magnet tucked away just out of sight. The pull is persistent, and it suggests that the marks left by a collision aren't just scars from the past, but active forces in the present. If we're being dragged toward an external neighbor, then the story of our cosmos is inseparable from whatever reality is sitting right next to it. It reveals a universe where the most significant events might be dictated by things we can't even see with a telescope. Every galaxy in that stream is an indicator that our world is being held and moved by a much larger, invisible hand. By tracking where these galaxies are headed, we are essentially mapping the coastline of a neighbor that exists beyond the edge of time. Math is the one thing that lets us look into parts of reality we can't actually see. We live in 3 dimensions of space and 1 of time, but for a long time now, researchers have been using string theory to try and figure out what's happening in the background. The idea is that the smallest pieces of the universe aren't points or dots. They are these tiny vibrating strings of energy. They are so small that an atom would look like an entire galaxy next to them. The way these strings vibrate is what decides everything, like how light moves or how much a grain of sand weighs. But the math for these strings only works if the universe has more dimensions than the ones we see. These extra dimensions are what create a space where a cosmic collision can happen. In this theory, our universe is like a thin membrane, and it's floating inside a much larger space called the bulk. This bulk isn't empty. It's a landscape where other membranes, other universes, can exist. Without those extra dimensions, there wouldn't be any room for a sibling universe to be there or to move around. These membranes can fold and stretch or wobble while they drift through the bulk. It's a picture of a multiverse where billions of different realities are all held in the same structure, and they each have their own physical laws. This is the framework for how a mark could be left on our reality. It shows that the edge of our universe isn't a wall. It's a flexible surface that reacts to pressure from the outside. When 2 of these membranes drift into each other, the theory says their surfaces can touch and exchange energy. The math gets very complicated there because it's trying to describe one world's physics meeting another world's physics. It's the moment where gravity and light and matter from both sides have to merge or compete right at the point where they touch. This makes things like the Great Cold Spot or dark flow seem like a logical part of a bigger system. Our universe is just a piece of a larger landscape where these collisions are a fundamental part of how the cosmos works. It's like we're living on a sheet of paper that's been pressed against another one, and the marks we see are just what happens when they interact. By mapping these dimensions, scientists are trying to understand the geography of the bulk. It leads to the question of what happens to the laws of nature at the moment of impact, when the boundaries between two realities go away and something new starts. There might be signs of something from outside our universe hidden right inside the atoms of the oldest stars. When you look at that first generation of stars, there is a specific way they are supposed to be built. They follow a chemical recipe we understand, where you expect to see certain amounts of iron and magnesium based on how elements form. But when astronomers actually look at the light from these stars, they see gaps. There are imbalances in the chemistry that the laws of physics we use right now can't really account for. It looks like something was there at the beginning that wasn't on the list of ingredients. The chemical record is missing things, and it suggests the material that built everything was mixed with something else. If two universes had a collision at the very start, it wouldn't just be energy or a flash of light. It would be a physical mixing of two different realities. They would each have their own rules and their own building blocks, and a crash like that would act like a contaminant. It would spill foreign particles or different physical constants into the soup of our early space. These ingredients would change how the first stars burned and how they eventually fell apart and scattered. Instead of everything being spread out evenly, we see these variations. We see chemical signatures that look more like evidence left behind at a scene than just a natural process. It makes you think that the ingredients here weren't all homegrown. We usually assume everything was made inside the boundaries of our own Big Bang, but the chemistry is saying something else. If we were hit by a neighboring universe, that point where they touched would be a place where different laws of nature were sitting side by side. That would leave a permanent mark on the oldest things in the cosmos. It puts the history inside the stars instead of just out in the open sky. It takes the idea of a multiverse and moves it from this massive scale down to the scale of an atom. The evidence for another universe might not be in some distant place, but in the matter we can actually touch and measure. We might be living in a reality that is a mixture of two worlds. Every time we find a star that doesn't follow the rules, we're looking at a survivor of that encounter. It turns these stars into a record, and it shows that where our elements came from is a much more complicated story than we thought. Soap bubbles drifting around are actually a good way to think about how universes might work. When you have two of those spheres moving toward each other, they don't just drift through one another. They collide and they press together, and right where they touch, they create this flat surface between them. It deforms them both for a moment before they either become one bubble or just bounce apart. Cosmologists think something like that might have happened to our own reality at the very beginning. They have a name for it. They call it cosmic bruising. The idea is that if our universe is just one bubble in a multiverse, a collision with another world would leave a mark. It would be this circular patch where the temperature is disturbed, pressed right into the fabric of space itself. These bruises wouldn't be messy or random like the other fluctuations we see in the sky. They would look like very distinct rings or circles. They'd have these specific borders that you can't really explain with the physics we have now. To find them, researchers have to look at the glow that's left over from the start of time, searching for patterns that are almost too perfect to be natural. It isn't just guessing either. Scientists have used supercomputers to run billions of simulations to figure out exactly what these marks should look like. They've made maps of these potential scars, looking for shapes that could only come from the pressure of something on the outside. If we actually found one of these circular imprints, the multiverse wouldn't be a theory anymore. It would be a reality. we'd have a literal map of where our universe ends and where another one started. It would be the proof that we were bumped by something outside of ourselves. It turns the sky into a crime scene where the evidence is just waiting. This search for those circular patterns in the cosmic static is a huge part of how data is analyzed now. Every new map of the sky is another chance to find a mark that shows we aren't just a lonely bubble floating in nothing. There is this strange thing about the temperature of the sky where 2 points on opposite sides are exactly the same. It doesn't really make sense when you look at how far apart they are. These regions are at the very edges of space, and they are so distant that light hasn't even had time to travel between them since everything started. Usually, if there's an explosion, you expect heat and energy to be all over the place and uneven, but the universe is incredibly uniform. They call this the horizon problem. It implies that every part of space was somehow coordinated before there were even stars. Standard science says the universe just expanded faster than the speed of light in a sudden burst to explain it. But the collision model looks at it differently, and it's more structured. It suggests these two massive universal sheets were already balanced while they were drifting toward each other in higher dimensions. They had billions of years to reach a steady, even temperature across their surfaces before they ever touched. So when they finally made contact, that uniformity was just transferred into our reality. The crash wasn't chaotic. It acted as a synchronizer that set the temperature for every point in space at the same moment. The most obvious mark left on our world isn't a specific spot or a movement, it's just how consistent reality is. It's a signature hidden in plain sight across the sky. Every time a telescope finds the background heat is perfectly level, it's seeing an inheritance from those parent worlds. This coherence suggests our origin wasn't a messy or accidental spark, but a structured event where the properties of two older universes were baked into our own. It forces you to rethink the Big Bang as a whole. Instead of a single point appearing out of nothing, we're looking at the result of a coordinated transition. The stillness and the balance in the deep sky are like lingering shadows of that contact. It means the laws of physics and how energy is distributed were decided long before our timeline officially began. We're just living in the aftermath of a perfectly timed encounter, and the order of the cosmos is the evidence for it. Subatomic particles act in ways that might actually be showing us a link to another world. There is this thing called quantum entanglement where two particles stay connected. So if one changes, the other one reacts immediately, even if they're pulled far apart. Usually, people assume those particles started out together right here in our own universe. But if the beginning of everything was actually two realities crashing into each other, that connection could reach all the way across the border. It would mean the matter in the stars and the planets, and even the matter in us, is still tied to things in a sibling world we can't see. This kind of link between universes would explain why things happen in the quantum world without any clear reason. Standard physics says there has to be a local cause for something to move or change. But we see these particles acting in ways that don't follow our laws, almost like they are being nudged by a ghost. If we're entangled with a neighbor universe, those particles are just responding to whatever is happening over there. The collision wasn't just a crash of heat and energy, it was a mixing of the building blocks of existence. It left an invisible thread that goes beyond space and time, like two colors of ink poured into one bowl. Even if you try to separate them, some of the molecules are always going to stay joined. Our universe might still be talking to that neighbor through subatomic probabilities. Every time a particle does something scientists can't predict, it could be a signal coming from the other side. So the impact wasn't just a bruise or a cold spot in the sky. It's part of how reality works at the smallest level. If we found proof of that connection, it would mean we aren't just neighbors with another universe, we're tied to it. We would be living in a place that is constantly being whispered to by another world. And the furthest edges of the multiverse would be as close as the atoms in your own hand. Dark energy is like this invisible force that keeps pushing the edges of the universe further out, and it's actually making that expansion move faster as time goes on. People have known the cosmos was growing for a long time, but there's always been this problem of what's actually fueling it. Usually, it's just talked about as a weird quality of empty space, but there is this idea of a cosmic collision that gives it a more physical explanation. If our universe is a membrane that pulled away from another one, then dark energy might just be the tension left over from that split. It's similar to a rubber band being pulled between two hands. As those hands move away from each other, the tension in the band gets stronger, and we feel that tension as a kind of pressure making our space swell up. It makes dark energy more of a relationship between two things instead of something happening on its own. It's not being created inside our own vacuum, but is more of a response to another universe moving away from us in a higher dimension. As these two worlds drift further from where they first hit, the energy density inside our universe has to shift to make up for that distance. So the galaxies flying away from us are really just a sign of a process that started with that original crash. We aren't just expanding into nothing. We're reacting to this past encounter that's still deciding how large our reality is. When you look at the sky this way, empty space isn't just a quiet void. It's more like a fabric that's under a huge amount of strain. There is a tiny bit of this energy in every cubic centimeter of the universe. And because there's so much space between all the stars, it adds up to a force that eventually becomes stronger than gravity. If this expansion is a relic of a bounce between these two universal sheets, then what happens to our world depends on how those membranes behave. We're just in this temporary state of stretching right now. It's driven by the momentum of a separation that started billions of years ago. And the acceleration we see through telescopes is basically the evidence of how hard we were hit by a neighbor we can't see anymore. Information might be the most fundamental thing there is, and it could be sitting right on the surface of reality. There is this idea called the Holographic Principle, and it says everything we see in 3 dimensions is actually an encoding on a distant boundary. It is like the security sticker on a credit card. The sticker is flat, but it holds all the data to show a 3-dimensional image when the light hits it. If that is how space works, then every star and every planet is just a projection from a flat sheet of information wrapping around the edge of the cosmos. It changes how we look for markers of a collision with another world. If 2 universes hit each other, they would have made contact at those boundaries first. And that encounter would have caused the information from both realities to mix and scramble right at the point of impact. Our world is a projection of that boundary, so the scar from a crash wouldn't just be a cold spot or a movement in one part of the sky. It would be baked into the foundation of how matter and energy are organized. Every atom and every galaxy would carry a tiny piece of that external data within its own structure. Detecting these holographic marks is difficult because they are woven into the background noise of the universe. It isn't as simple as pointing a telescope and looking for a shape. Scientists have to use math to look for patterns in how galaxies are distributed across billions of light years. They are looking for subtle irregularities that don't belong to our local physics. Small mathematical glitches in the projection that show our world was influenced by a different set of data from a sibling universe. The entire sky is like a giant hard drive that has been recording the history of its own birth since the first second. We are essentially living inside a record-keeping device. If the holographic principle is correct, then the evidence of our origin isn't lost to time. It is preserved in the data that defines our space. Finding it would mean we can reconstruct the exact moment 2 universes met by reading the information printed on the edges of our own reality. As technology and our understanding of physics improve, we are getting closer to being able to scan that cosmic boundary. It opens up the possibility of seeing the physical laws of another world reflected in the patterns of our own. Every new map of the distant universe is a chance to decode these messages and understand the structure of the larger reality our world belongs to. Everything we see depends on these very specific mathematical values. Numbers that have to be exactly what they are, or the stars wouldn't have been able to form at all. It's what scientists call fine-tuning. It's a massive puzzle because every force, like gravity or the way light behaves, relies on these precise constants. If the force holding atoms together changed by even a tiny fraction, you wouldn't have a complex universe, just a cold cloud of hydrogen. There is this idea now that this balance wasn't just luck, but that it came from a collision. The thought is that when two universes hit each other, the impact filters the laws of physics. All that energy and pressure from the crash decides which constants stabilize and which ones just disappear. So the numbers we have now, things like the speed of light or the mass of an electron, they are basically the marks left behind by that encounter. Our universe ended up in this specific state because it was the only version that could survive the angle and the speed of that strike. If that other universe had hit us differently, with more force or from another direction, everything might have stayed sterile, or the whole thing could have collapsed before an atom even moved. It changes how you look at a collision. We usually think of a crash as something that just destroys things, but in a higher dimension, it's actually how things are created. The fine-tuning of our physics is the signature of that transition from chaos into order. It means the conditions for life weren't a random accident in a vacuum. They were carved out by the pressure of another world pushing against ours. When we measure these fundamental forces, we're looking at the remnants of that first contact. We are only here because of the specific conditions of an event from billions of years ago. It makes the universe feel less like a machine and more like the result of a much larger process. We're just living in the stability that followed, and these numbers are the marks left by that neighboring reality. The only way we can really see how a reality begins is by using supercomputers. It's where scientists build these digital landscapes to look for marks as old as the universe. And they do it by creating entire multiverses out of code. They let thousands of these digital bubble universes drift around and collide in a virtual vacuum. These aren't just visual effects, though. They're mathematical playgrounds that show how the fabric of space-time reacts when something hits it from the outside. When these virtual worlds touch, they don't just bounce off each other. They leave behind these complex wake patterns in the energy of the vacuum. It looks a lot like the ripples you see behind a boat moving through calm water. And these wakes are incredibly durable. The models show they can last for more than 13 billion years without ever fading away. Researchers generate thousands of different collision scenarios to predict the shapes and the temperatures and the gravitational signatures an impact would leave behind. Then they take those digital blueprints and overlay them onto real maps of the cosmic microwave background. It's a process of elimination on a universal scale. If a pattern in the computer matches a cold spot or a cluster of galaxies in the actual sky, it gives them a statistical smoking gun for a past collision. These labs let us see the invisible by turning equations into three-dimensional models of colliding realities that can be studied from any angle. As deep space probes send back more data about the texture of the sky, the simulations get more accurate. Every pixel gets us closer to knowing the details of our own cosmic crash, like the angle of the hit or how big the neighboring world was. We're using these tools to look back at the most distant event in the past. This computing is what's unlocking the secrets of the bulk, turning the multiverse from a philosophy into a physical map. It shows that the scars in the stars might have a logical explanation in the math of how worlds interact. Measuring the whole sky gives you a surface that looks completely flat, and it seems to go on forever in every direction. Most scientists just assume there isn't a curve to the universe, and it's the same way the Earth feels flat when you're standing in a big field. But when you look at things on a cosmic scale, even a tiny shift away from that flatness changes what we know about where we came from. If the universe was just an isolated event, the geometry should be mathematically perfect. But a collision with another universe would leave a permanent dent, or a warp in space and time. It would be like pressing your thumb into a bowl of soft clay and leaving a depression that changes the whole shape of the thing. We have high-precision instruments now that are looking for those small geometric flaws. If we find even a fraction of a percent of curvature, It would mean the universe has a boundary that was pushed in by something on the outside. That mark would be a map. It would show the exact spot where our reality hit a neighbor. It takes the ideal away from an infinite plane and suggests we live in a structured shape with a history. If space curves, there's a limit to reality, and that limit was set by the weight of a sister universe. Finding that would rewrite the laws of cosmic topology. We wouldn't see the universe as a self-contained box anymore, but more like a flexible sheet that gets bent by external pressure. Searching for this curve is about finding evidence that our space isn't a blank slate. It's a surface that has a physical memory of an encounter. When we map a bend in the sky, we aren't just looking at stars. We're looking at the footprint of a world that was there before ours. It changes the context of every distance we measure, because the floor of the cosmos might be sitting in the indentation of an older strike. What we think of as the beginning might have just been one moment in a process that never really ends. It's possible the collision that started our time wasn't some isolated accident, but part of a larger rhythm where these two universal membranes are constantly coming together and then pulling apart again. Physicists talk about it like a cosmic accordion. You have these two sheets of reality drifting through a higher dimension, and gravity keeps pulling them toward each other across that gap until they finally touch. That contact creates a massive flash of energy and a new universe starts, but they don't stay together. They bounce off and move away, and as things cool down, that's when the stars and galaxies have room to grow in the space between them. It's this cycle of rebirth that just goes back forever. In that framework, the Big Bang was really just the most recent impact in a long series of events that have happened countless times before. Every time they crash, it resets the matter and the radiation, but the slate might not be wiped entirely clean. There's a chance that certain massive structures or gravitational signatures from whatever came before could actually survive the heat of a new impact. It would be like seeing faint indentations on a piece of paper that was erased and then written over. We could be looking at the sky and seeing the ghost of a universe that existed before this one, just a layer of history sitting underneath the stars we see now. It takes away the need for a starting point where everything comes from nothing. You get a sense of continuity instead. Every atom we're made of could be recycled material from a cycle that happened trillions of years ago. It suggests we're just in a very specific season of the cosmos, this period of expansion that will eventually hit a limit. Once the momentum from that last bounce fades out, the pull between those two sheets takes over again. The gap starts to close, and the universes begin falling toward each other for the next encounter. You start to wonder where we are on that timeline. If the marks we see in the sky are from the last contact, then we're probably at the point where the two worlds are furthest apart. We're living in the quiet part of the bounce. But the cycle says gravity wins eventually, and there will be another flash of light that rewrites the laws of physics. It makes the universe feel less like a lonely thing and more like a recurring part of a stable system. We're just the latest witnesses to a history written into the fabric of space, waiting for the next time those membranes meet. There is a possibility that a cosmic crash left a mark on the chemistry of everything around us. When researchers look back at the first few minutes of the universe, they use nucleosynthesis to figure out what was happening. It was a time when things were so hot that particles were fusing into the very first elements, mostly hydrogen and helium. The math for those two works out, but lithium is different. The numbers just fall apart there. If you look at the oldest stars, there should be 3 times as much lithium as what we are actually seeing. This has been called the Lithium Problem for decades. It is this missing material that doesn't make sense. One idea is that the answer involves physics from somewhere else. If the beginning of time was actually a collision between two different universes, it would have been much more complicated than just an explosion. You would have had exotic particles or radiation coming over from a sister world. Those foreign influences would have changed how that early soup of particles reacted. They would have acted like a catalyst. In that kind of heat, with those outside forces present, the lithium might have just burned away. It could have transformed into something else entirely before the universe even had a chance to cool down. The missing matter is almost like a fingerprint left at an accident. We usually expect the signs of a collision to be something like massive holes in the sky or the way galaxies move. But this suggests the impact went all the way down into the building blocks of matter. Every atom of lithium that isn't there is a clue in a cold case that is billions of years old. It shows that an encounter between two realities had physical consequences we can actually measure in a lab. The universe looks like it was chemically altered by its neighbors. Our origin story is written in what is not there, and it suggests the vacuum was never as simple or as lonely as we thought. If you find where that lithium went, you might find proof of a world beyond our own. Everything we see is built on these hidden dimensions that we can't actually perceive. We move around in three directions, but the math points to these other paths that are curled up so small they stay invisible to us and our tools. These dimensions aren't just something physicists use to make the numbers work out. They are a physical necessity for how the universe exists. There has to be this extra room for these universal membranes to move or wobble around, or there wouldn't be any way for them to eventually crash into each other. These hidden spaces provide the distance that allows one reality to touch another. The impact from a collision like that would leave a mark on the shape of those invisible dimensions. When the universes hit, the force could have twisted or crushed that higher geometry. It's a process called compactification. The way those dimensions ended up being folded is what determines the laws of physics in the world we can see. The strength of an atom or the way gravity and electromagnetism work are all dictated by the specific curves of that hidden landscape. A collision that powerful would have basically reprogrammed the settings of our reality. The geometry of the invisible would be permanently changed, so the signature of that strike is sitting in every single point of space. It makes the whole universe a map of that impact. We look for scars in the stars or cold spots in the sky, but the evidence might be right in front of us. When light moves at a certain speed or an object falls, we're seeing the result of how those dimensions were shaped during the crash. We are living in the aftermath of a total structural change. The laws of nature aren't random. They are the leftovers from when the fabric of reality was being pressed and folded by an outside force. Trying to understand these dimensions is the limit of what we can know about the world. It's at the edge of what we can even visualize, this shape that exists outside our perspective and holds space-time like a thread in a weave. If we can decode the geometry of those paths, we'll have a way to see the mark of the world that hit us. It takes the theory and makes it something we can find right in the palm of our hand. The most important parts of the story are just hidden in the shadows of these dimensions we're starting to name. The ancient sky map shows more than one anomaly. That big cold spot in Eridanus isn't alone. New, high-resolution studies of the cosmic microwave background found a cluster of smaller temperature anomalies around it. They form a faint pattern like a constellation of scars, and that's important. A single mark could be a fluke, just an accident in the data, but a pattern of spots tells a different story. It suggests the interaction between our universe and its neighbor wasn't a simple, head-on strike. It was more likely a complex, glancing blow, with multiple points of contact as the two membranes slid past each other. Think of a shattered car windshield. The main impact creates a central crater, but radiating out from it are dozens of smaller cracks and chips. By studying that pattern of cracks, a forensic expert can reconstruct the angle, the speed, even the shape of the object that hit the glass. These smaller cold spots near the main one are those secondary cracks in space-time. They're giving cosmologists a detailed, three-dimensional map of the collision. By analyzing the spacing and temperature of these marks, scientists can start to calculate the velocity and the trajectory of that other universe. Was it a swift, direct hit? Or a slower, more tangential graze? The pattern holds the answer. This changes the theory. It goes from a single, puzzling observation into a robust, interconnected system of evidence. A random statistical fluke wouldn't create a coherent, localized pattern like this. The presence of these neighboring anomalies makes the case for a cosmic collision much stronger. It turns the sky into a detailed forensic record. Every cold spot is a data point, a witness to a specific moment in that ancient encounter. We're not looking at a single bruise anymore, but at the full footprint of an impact. This detailed map lets researchers move past asking if a collision happened and start asking how it happened. What was the nature of the contact? How long did it last? The story written in the cold is getting clearer with every new piece of the pattern we find, guiding us toward the final pieces of the puzzle. We're about to get a much sharper look for that cosmic bruise. In the next few years, a new generation of space observatories is launching. Their main goal is to map the invisible structure of the cosmos in detail we've never had. Missions like the European Space Agency's Euclid Telescope and a Nancy Grace Roman Space Telescope. They're not just upgrades, they're entirely new classes of instruments, built to see what current telescopes can't. The subtle warping of space from dark matter, the faint echoes of ancient gravitational fields. These tools are designed to hunt for the specific distortions a collision with another universe would leave. It's like moving from a basic camera to a high-resolution medical scanner. For decades, we've been looking at a blurry image of the cosmic microwave background, guessing at shapes in the static. These new telescopes will scan billions of galaxies. They'll measure how their light is bent by the gravitational pull of all the matter in between both seen and unseen. That process is called weak gravitational lensing. It will create a three-dimensional mass map of the universe. And it's in that detailed map that scientists hope to find the definitive signature of an impact. A region where the distribution of matter shows a clear, coherent pattern of disturbance. Something no known process in our own universe can explain. Like finding a fossilized footprint in stone. The shape and depth telling the story of the creature that made it. The data from these missions will be staggering in volume and precision. It lets researchers test the collision model with a rigor that was impossible before. They can measure the exact size, temperature profile, gravitational pull of anomalies like the Great Cold Spot. They'll look for the predicted ring-like patterns, the correlated temperature shifts the simulations have been forecasting. This isn't just taking a better picture. It's conducting a forensic analysis of space-time itself. We're moving from speculation to direct measurement, turning a compelling theoretical idea into an observable, quantifiable fact of nature. This technological leap puts us at the threshold of a profound discovery. Within the next decade or two, the evidence from these observatories will likely force a definitive conclusion. Either we find the clear, statistical imprint of another reality pressed against our own, confirming our universe is part of a vast multiverse, or we find the anomalies can be explained by new, undiscovered physics within our solitary cosmos. Both outcomes are revolutionary. One confirms a collision that shaped everything we know. The other sends us back to the drawing board to conceive even bolder ideas about cosmic origins. We're not just staring at the sky and wondering anymore. We're building the tools to read its deepest history, waiting for the moment the data reveals whether we've always been alone. The physics changes, but the story changes too. For centuries, we thought we were at the center of a unique creation. But if we came from two other realities colliding, that specialness goes away. We're not the main event. We're a consequence, a byproduct of a process that probably repeats across an endless landscape of worlds. Our universe, with all its galaxies, might just be one ripple in a sea of collisions. And that carries a weight. It asks us to reconsider purpose. If our origin was an accident of geometry in a higher dimension, does that make us meaningless? Or maybe it makes us more remarkable. It shifts the narrative. From a singular, destined creation to an improbable emergence, we're not the planned outcome of a solitary beginning. We're the complex result of a cosmic interaction. The mark on our sky isn't just a physical scar. It's a symbol, a permanent reminder that we're part of something larger than our own horizon. It forces us to expand our idea of home. Beyond the Milky Way, beyond even our observable universe, home becomes the entire, unseen structure that birthed us. That perspective brings humility. We're not the pinnacle of a linear progression. We're a moment in a cyclical dance of realities, but it also sparks wonder. The same laws that allowed stars to form and life to emerge were forged in that violent impact. The fine-tuning that makes our reality possible wasn't a gift from nothing. It was a signature, carved by the specific conditions of that ancient encounter. We are children of that collision. Our atoms carry the memory of that meeting. So are we merely debris? Or are we participants in a grand, multi-dimensional ecosystem we're only beginning to sense? The theory invites us to see the beauty in our own scars. The cold spots, the strange flows, the missing lithium, these aren't flaws in the design. They are the design. They're the evidence of our connection to a wider family of existence. This shift from isolation to interconnection is as significant as any telescope's discovery. It asks us to look at the night sky not as a ceiling, but as a window. And through it, we're starting to glimpse the outlines of our true neighborhood. Time might be the deepest scar from that crash. We live in a universe where moments only go one way, from past to future. And that's because of entropy. It's a measure of disorder. The rule is it always increases. You can break an egg, but you can't put it back together. The universe started with incredibly low entropy, a state of perfect order, and it's been unwinding, becoming more disordered ever since. That unwinding is what gives time its arrow. The big question has always been, why did it start that way? Why such a low, ordered state? The collision model gives an answer. When those two membranes slammed together, the impact didn't just create heat and matter. It created an immense, structured gradient of energy. Think of it like winding up a clock. The force of the collision took the chaotic, high-entropy energy of the two parent realities, and it concentrated it, organized it into a tight, low-entropy spring for our new universe. That spring has been slowly uncoiling for over 13 billion years, driving every process we see, the fusion in stars, the growth of a tree. Every change relies on that initial, ordered state. Without that precise winding from the crash, our universe might have been stillborn. A featureless, high-entropy fog, where time had no direction, where nothing could ever happen. So the forward march of time isn't a fundamental property. It's a historical artifact, a momentum passed to us from that singular event. Every second that ticks by on a clock, every memory you form, every irreversible change from youth to age. It's a direct, lingering echo of the energy released when two worlds met. The mark of the collision isn't just out in the distant cosmos. It's woven into the fabric of our conscious experience. It's the reason we perceive a past that's fixed and a future that's open. Time is the most intimate evidence of our violent birth, felt in the heartbeat of every living thing. This connection makes it personal. The multiverse isn't an abstract concept far away. Its legacy is the very flow of your life, the reason you can learn from yesterday and hope for tomorrow. The arrow of time points back to that moment of contact, making our daily reality a continuous, living testament to an encounter that shaped the fundamental rules. We are not just in time, we are of it, a product of that first, definitive push into history. The clues come together, they form a new story. It's startling. The Great Cold Spot isn't just an oddity, it's part of a larger pattern. That pattern includes the strange pull of dark flow. It includes the tilted alignment of the axis of evil. And it includes the elegant mathematics of brane worlds. On their own, each anomaly could be a fluke, a gap in our models. But when you put them side by side, a coherent story starts to appear. They aren't random errors, they're interconnected symptoms of a single, profound event. It's like a forensic report, a report of a universe-shattering event, written across 13.8 billion years of cosmic history. The evidence suggests our universe didn't appear from nothing, it transitioned, it came from a prior state. A state marked by an encounter with another reality. This synthesis of theory and observation brings us to the edge of a new understanding. The Big Bang wasn't a beginning, not in the absolute sense. It was a transformation, a moment where the energy and structure of two parent worlds were forged into one. The one we call home, so the cold spot is the bruise. The dark flow is the lingering gravitational tug. The axis of evil is the directional scar of the impact. And the mathematics provides the blueprint. The blueprint for how such a collision could even be possible. We're assembling the pieces of a cosmic puzzle. The picture they reveal isn't of a solitary, self-contained cosmos. It's of a world born from contact. This changes the fundamental question of our origins. We're no longer searching for what sparked the first moment. We're investigating what came before that moment, and what left its indelible mark upon us. The mystery deepens, but the path forward becomes clearer. Every anomaly is a guidepost, pointing back to that ancient, formative encounter. And as we stand at this precipice of understanding, we're compelled to ask the final question. The most profound one this evidence forces upon us. What does it truly mean for our place in existence, if our entire reality began with a collision from beyond? That final question stays with you, long after the data. We were looking for a mark on the sky, and it led us here, to a place where science and philosophy come together. This collision between universes, it's not just a theory about our past. It's a lens, a way to reimagine everything, the cold spots, the strange flows. The arrow of time itself, they aren't separate puzzles, they're chapters in one story, a story of contact, written into the geometry of space, and that idea, it changes the cosmos. From a lonely stage to a neighborhood, we're not just passive observers anymore, not of a static universe, we're participants in something dynamic, interconnected. Every anomaly we map, every pattern we decode, it brings us closer to understanding our place in that architecture. These marks, they're more than scars. They're signatures, handwriting from another reality, pressed into the fabric of our own. They tell us our origins are woven from a collision, a moment of transformation. That set the rules for everything. So as we build better telescopes, run more detailed simulations, we're not just testing a hypothesis. We're learning to read that handwriting. Deciphering a message, over 13 billion years old, and the message says we're not alone. Not in the sense of life out there, but in a deeper way. Our universe has siblings. It has a history that stretches back before what we call the beginning. And that changes everything. It redefines home. It redefines destiny. It asks us to look at the night sky differently. We're not gazing into an empty void. We're looking at evidence, the living evidence of our own birth. A birth born from an encounter with the unknown. So the questioning, the wondering, it has to continue. This journey to understand our place, it's just starting.